Welcome everyone. I think we have gathered a nice group. There is probably more people coming, but I will already start by welcoming you at this ECOSYSTEX webinar, which is the third dissemination webinar of the ECOSYSTEX community. And as everyone arrives, I will already guide you through the webinar procedures. As you can already see, this webinar is being recorded and will be shared on public channels afterwards. So please, in case you would not like to appear in this recording, then please turn off your video and your audio and keep it like that all times. Please also mute your microphone in any case, just to avoid that we have any echo or background noise. Please also disconnect your video so that we can always focus on the speaker of the moment and the presentation. In case you have any questions during the webinar, please write it directly in the chat and also mention the name of the speaker to whom you address your questions so that we can later on take it up and address during the Q&A, which will take place at the end of this webinar. In case during the Q&A you have another question, you would like to speak or elaborate on your question, then please raise your hand and we will give you the floor to speak. And of course, then unmute your microphone. And if you can, then also turn on your video so that we can see who is asking the question. So again, this is the third dissemination webinar of the ECOSYSTEX community. The agenda today will be running from 10 a.m. to 12 a.m., at least here in Brussels. We will have 3 projects presented today: Aligned, WhiteCycle, and HereWear. 2 of them are fairly new members of the ECOSYSTEX community. However, HereWear has been with us for a long time. They already presented themselves in last September, so this is going to be an update on the work that they have done so far. After all the 3 presentations, we are going to have a Q&A moment, as I already mentioned. We can definitely address any questions you might have, and then we are going to wrap up to finish hopefully well on time. Before we start, I would like to introduce ECOSYSTEX briefly to those of you who wouldn't be familiar with the concept, with the community. ECOSYSTEX is the European Community of Practice for a Sustainable Textile Ecosystem. And what is interesting about it is a community of projects. So we have 19 EU research projects which focus mostly, exclusively actually, on textile circularity and sustainability. And we wish to enhance cross-project expert collaboration on topics of common interest within this community. We also work on providing expert input to EU policies on the fields of research, standardization, SME support, and sustainability. We also organize joint dissemination for all these projects, and today's webinar is a very good example of that. The formal launch of ECOSYSTEX happened late this January, so it's a fairly new concept. However, we started to work on it already last September. So there has been quite a long procedure of preparation, also a lot of work with the involved projects to finally make it happen and go public with a very nice and rich network of projects under the logo of ECOSYSTEX. The management of this network is done jointly by the European Commission's Research Executive Agency and by the Textile ETP, which I'm representing here today. Just a look at the 19 member projects that I just mentioned. You can see all the logos here, and you will hear 3 of them today. And with that, I would like to already invite the first speaker. We are going to hear first about the Aligned project. Marisa Groenestege will present it from the BTG Biomass Technology Group. So I invite Marisa to take over the screen and start the presentation.
Yes, thank you, Camilla, for the introduction. I will share my screen. Okay. Do you see it?
Perfectly.
Yes, okay. Well, welcome everyone. My name is Marisa Groenestege and I work at BTG Biomass Technology Group, which is an SME based in Enschede, the Netherlands. And today I will be presenting the Aligned project. So first, what is BTG? So BTG is an independent private SME company that is dedicated to energy materials that are produced from biomass. So it is a unique combination of consultancy, RTD, and project development. And we have more than 25 years of experience with over 1,500 projects, 55 units and plants, and 15 spin-off companies. So we do projects that are from pre-feasibility up to implementation, and we have expertise that span the entire value chain from biomass to energy and materials. And we have extended knowledge on gamma aspects and knowledge transfer. And we have experience with the formation of consortia and the cooperation in large European projects, such as Aligned. So recently, BTG carried out the study Biorefinery Pathways and Outlooks for Deployment, and where we found that there is a lack of evidence on sustainability and that there are many sustainability claims and labels, which lack comparability, especially between the different sectors. There are also other barriers, such as the costs, the definitions are unclear, making the LCAs open to interpretation. And in many cases, there is a lack of financial incentives, which makes it hard to compete with fossil-based products. So there are many different sustainability claims and labels, which can also reduce its effectiveness. And also these claims and labels differ per sector, which makes comparing them also even more difficult. For example, there are some labels that are very specific to the textile sector. So the terminology can also be confusing to both the people that are applying these methods, but also to consumers, which are some of the reasons that the Align project came to be. So the end goal of the Align project is to improve the overall sustainability of products. And we want to do this by improving the methodologies that aim at measuring and demonstrating the environmental sustainability of these products and materials. So we believe that the bioeconomy and bio-based products hold the promise of potentially reversing climate change, restoring biodiversity, and protecting air, water, and soil quality in the EU, but also across its borders. So as such, the EU issued a call to improve the environmental performance of 5 bio-based sectors, namely in construction, in woodworking, textiles, pulp and paper, and in biochemicals. And we applied, and our project was one of the 2 projects that was selected for funding together with our sister project, Calimero. So we want to do this by advancing advancing the field of life cycle assessment, also known as LCA. And we will be doing this with collaboration with industries and representatives from the 5 bio-based sectors. So again, construction, woodworking, pulp and paper, textiles, and biochemicals. So first, what is an LCA? So LCAs can be used to assess the environmental impacts of materials, products, and services through every phase of its life cycle and can be applied to a wide range of industries, including the textiles industry. So it can be used as a decision-making tool towards sustainability. However, to compare the environmental impact of 2 or more products and choose the more sustainable one, these impacts have to be measured in a similar way. So as such, the Align project will take a look at LCA methodology and aims at improving, harmonizing, and aligning LCA assessment methods in the bio-based sectors. So why are we looking at textiles? So global fiber production has quadrupled in the last 50 years. So while a part of this can be explained by the population growth, the increase in fiber production is largely due to an increase in consumption of textiles per capita, which has doubled in the last 50 years, as you can see on the screen. Similarly, the number of times that a garment is worn has decreased with about 40% in the last 15 years. So both this increasing textile consumption and a declining clothing utilization rate are largely due to the uptake of fast fashion, which is a phenomenon in which there is a quicker turnaround of new styles and there are more collections offered every year. So fast fashion goods often have lower prices and inferior quality, and this industry is dependent on cheap synthetic fibers, which has also caused a spike in the demand for fibers such as polyester and polyamide. So as can be seen in the figure, the production of synthetic fibers is now more than 7 times higher than it was 50 years ago. So in 2021, global fiber production amounted to 113 million tons, of which 2/3 consist of synthetic fibers. So less than a third of fiber production is plant-based, and there are small shares of man-made cellulosic fibers and animal fibers. And this large production of fibers and synthetic fibers has led to some major environmental impacts. So the sector is a large emitter of greenhouse gases. Its emissions totaled 1.2 billion tons of CO2 equivalent in 2015, which is more than the emissions produced by the maritime and the aviation sectors combined. So the textile sector also consumes about 4% of all fresh water extracted per year. So in 2017, the sector used about 93 billion cubic meters, which is enough to meet the consumption needs of 5 million people. So the sector's water use is expected to increase with 50% by 2030. And climate change is expected to increase water insecurity and scarcity in many regions of the world, especially in Asian countries, which are very important to the textile production. So the textile sector is also a major consumer of fossil fuels. In order to produce 1 kilo of synthetic fibers, 1.1 kilo of petroleum oil is used. So while the sector now uses about 100 million tons of petroleum oil annually, this is expected to triple to about 300 million tons in 2050. So a lot of chemicals are also used to produce textiles, with almost 500 grams of chemicals used for 1 kilogram of synthetic fiber and 925 grams of chemicals for a kilogram of cotton material. So an estimated 5% of the world's cultivated land is currently dedicated to producing fibers or materials for the textile sector, which is expected to increase to 7% in 2030. Fibers are also being released into the environment during the production, the use, and the end-of-life disposal of textiles. So synthetic fibers with a length of under 5 millimeters are also known as microplastics, and the majority of microplastics from textiles are released during the first washes of textiles. So the spread of fast fashion has led to more first washes, as these clothes are usually only worn a short time and are worn out quickly. And these microplastics can end up in various ecosystems, especially in marine environments, such as shorelines, waterways, and oceans. And microfibers are being ingested by all kinds of living organisms and are impacting ecosystems, as well as human and animal health. And lastly, there is the problem of end-of-life waste. So large amounts of clothes are being produced and are quickly worn out, generating large amounts of waste. And fibers from textiles have traditionally been difficult to recycle, as less than 1% of pre- or post-consumer recycled textiles were used for similar applications, such as garments. And 12% of textile waste is reused, but for lower value applications, such as insulation materials or mattress stuffing. However, the far majority of textile waste ends up in landfills or incinerated. So especially natural or bio-based fibers, they have shown to be difficult to recycle, as traditional mechanical recycling methods has led to major reductions in fiber length. So this results in fibers that are too short to be spun into a yarn of a proper strength. And this, and also the increasing use of mixed fabrics has led to recycling being more difficult, as many types of fibers that are used need to be sorted and separated and then recycled individually. So how will we try to improve this in the Align project? So our goals are to improve and harmonize and align LCA methodology for the assessment of bio-based industries. And we also want to cover environmental and socioeconomic aspects. We want to demonstrate the power of methodology on the 5 specific technology development cases in 5 industries, and to improve their environmental performance. We want to inform, involve, and empower all relevant stakeholders. We want to enable an efficient methodological uptake and practice improvement to support the sustainable growth of the bio-based sector in Europe. So the figure on the screen will show you our methodology. So we want to advance the scientific field of life cycle assessments, and we want to do this by collaborating with industries and representatives from the 5 sectors. So we will develop a modeling framework to perform assessment studies across these sectors. And then the framework will be tested and improved through an application in 5 specific cases. So we will have 5 case studies, 1 for each sector. And at the same time, we will be in close communication with stakeholders from the 5 sectors to receive their feedback and for us to learn what the wants and the needs are from people in the sector when it comes to environmental sustainability and its assessment. So what impacts do we want to have? So at the end, we will deliver aligned and simplified methods that can be used to assess environmental performance in the 5 bio-based sectors. So these methods will include several key aspects that are relevant to the sectors, such as land and biomass competition, carbon accounting, biodiversity, and uncertainty handling. The project aims at improving the environmental performance of the 5 bio-based 5 industrial processes, and by sharing these results and solutions with the key stakeholders from these sectors. And finally, we will also disseminate this information on the environmental performance in the 5 bio-based sectors and give recommendations about how to improve it. So by improving the environmental performance in the 5 case studies, by aligning LCA methods for the 5 sectors, simplifying LCA methods and giving recommendations to the sectors about these key aspects within LCAs, we want to help improve the LCA methodology and the overall environmental performance. So in the end, we aim at increasing the growth of circular bio-based systems that help protect the environment. So all the companies you see on the screen are the consortium of the project. So on the left, you see 4 universities. So the University of Aalborg in Denmark is the coordinator of the project. And we also have the University of Antwerp. We have INSAT in Toulouse in France, and NTNU, which is based in Norway. And together with BTG, we will develop LCA methodology and apply this in 5 case studies, which will be done in the 5 companies, which are shown in the middle. So the case study for the construction sector will be with Kingspan, woodworking will be with Foreco, pulp and paper will be with Bloom, and biochemicals will be with Oleon. Finally, for the textiles case study, we are working with Utexpel and Centexpel. So Utexpel is a textile group in Belgium, and Centexpel is the Belgian sector organization for the textiles industry. And finally, there is also Sustainable Innovations, which is our communication and dissemination partner. So our role in the project as BTG is that we will be doing 2 LCA studies. So one in the textile sector, which I will explain shortly, and one in the biochemical sector. Additionally, we are also in charge of some information about the sectors, and we are also handling all the stakeholder activities. So our case study partner is Utexpel, which is a Belgian family business founded in 1929, and it is a vertically integrated process from fiber to fabric. It has 900 employees and mostly works for public tenders and protective wear, as well as fashion and technical applications. So these are some of the products that Utexpel produces, and most of them are based on certified fibers. And as you can see, there are some cotton fibers used and some blends, and most of them have certifications such as GOTS or BCI, FSC, and GRS. So the case study that we will handle within the Align project is we will focus on the product called Dr. Green, which is a recycled product from end-of-life hospital garments, which is work clothing that contains both polyester and cotton fibers. And it can be recycled using a new technology that Utrechtspel has developed. So these polyester fibers are more easily recycled into new clothing, and they are combined with new organic cotton fibers. So some things that we will consider in a case study is the collection of cotton dust, and we will look if it could be used as an input for chemical recycling methods. So we also want to look at colored garments, as the current recycling process mostly focuses on uncolored garments. But also, of course, the material stream needs to be homogeneous. So this is something that we will consider. Also, we will look at the material efficiency, as currently the hard parts and the colored parts are being removed in a social workplace. So we will also take a look if it can be removed automatically. And we will also consider if we can recycle at multiple stages. So we will not only consider environmental impacts, but we will also look at economic and social impacts. So on the screen, you see some of the impacts that we will consider. So for environmental, we will look at whether organic cotton does require less water and fertilizer, if we use less virgin materials, as we are reusing materials as well. And we will also look at the environmental impact of a more local production with shorter supply chain. Additionally, we're also taking the economic impacts into account. So for example, we will take a look at how this will impact the local textile production, and it's in the knowledge there. And finally, also the social impacts, as currently we are using, or in the company, they are using a social workshop in which the hard and colored parts are removed. So as I said before, we are also in charge of the stakeholder activities. How do we want to, what do we do with the improved LCA methodology and the learnings from the case study? So our final results will be the recommendations about LCAs that are applicable to the textile sector. So in order to translate our learnings into something that is applicable to the entire sector, first we are doing the case study, of course, but then we want to translate our learnings into something that is applicable to the entire sector. So first, we have made a sector overview, which describes the overall state and structure of the sector, the materials that are used, especially the bio-based materials and their applications, and then also the environmental impacts of these materials and the ways that they are assessed. So in order to verify these results and to gather the opinions of people from the sector about environmental sustainability and its measurement, we are currently having an online consultation. So as I said, we are in charge of the stakeholder activities for the Align project, but I will tell you a little bit more about this in a minute. So next, we want to present our first results and to get further feedback from people in the sector. So we are having a workshop, which I will also talk about in a minute. So these stakeholder activities will help us get insights and a better overview of the environmental sustainability in the textile sector, and will help us translate our findings into recommendations about LCAs that are applicable to the entire sector. So the online consultation. So if you want to share your opinion and your knowledge about sustainability in the textile sector, we would highly appreciate it if you could fill in our online consultation. It will be a great help to our project, and by sharing what you find most important, it will also help us shape the project and make sure that the things you find important are included as well. So the consultation takes about 5 to 10 minutes to fill in. It's in the form of an online survey. It has a little over 10 questions, and most of them are multiple choice. So even if you're not an expert, your opinion is still very welcome, and all the questions are optional. So feel free to skip any questions you're unsure about. And as I assume that you might not have the time to fill it in now, you can also find it on the Aligned website, which you can see on the screen. And it should be the first thing that pops up when you go to our website, which is alignedproject.eu. So as I said, we will also be having a workshop soon, so in about a month's time. So if you want to be kept up to date with our future events, such as this workshop that we will be holding, please join our stakeholder network. So stakeholders will not only receive our newsletter, but will also get more information about events that we will be holding for the sectors that they're interested in. And we will also post more information about this, as well as the workshop, on our website and our social media channels, which you can see pop up here. Yeah. And that was my presentation. Thank you all for listening. If you have any questions, of course, you can ask it later, but also feel free to email me. My email address is shown on the screen. Yeah.
Great. Thank you so much, Marisa, for your very comprehensive and interesting presentation. I see there is already one question in the chat, but I would also like to invite everyone else to ask a questions through the chat if you have anything that you'd like to address Marisa with, and then we are going to take it up during the Q&A at the end of the webinar. And with that, I would like to already invite our second speakers, actually 2 of them. It will be a joint presentation about the WhiteCycle project delivered by Sebastien Noël and Christophe Leclerc from Michelin from France. So I invite you to share your presentation and take the stage.
Hello, everyone. Hello. Do you see our screen? It's okay for everyone?
Looks good, and we also hear you very well. So perfect.
So let's go. So with Christophe, we are going to present you today the WhiteCycle project. So my name is Sebastien Noël. I'm the coordinator of the project. I'm working for Michelin R&D Center in Clermont-Ferrand.
And I'm Christophe Leclerc. I am the technical director of WhiteCycle project. Nice to be at that meeting. Thank you.
So you can see the website of the project or LinkedIn if you want more information our discussion today. So what is WhiteCycle? So the goal of WhiteCycle is to recycle a complex waste containing PET. So when we talk about complex waste, we are talking about complex garment clothing, but also tires and lay flat hoses. So if we look at the quantity of this complex waste containing PET today and which are not recycled, it's quite huge. So if you look on the plastic side, if we consider the tires and the flat lay hoses, we have 3 million tons possible for this kind of feedstock. And for clothing, we talk about more than 13 million of tons each year. So just to give you some details, so for clothing, I think it's evident for everybody what kind of PET can be contained. For tires and flat lay hoses, just few elements. So if you look at a tire, you can find PET in what we call the carcass ply of the tire, which is we can say the skeleton of the tire. So these PET yarns are used for reinforcement, for the tires. And when we develop a tire, we put a lot of energy to have how could I say, a very strong adhesion between these yarns and the rubber in the tires. And then it's also very difficult to, at the end of the life of the tire, to separate these PET yarns with a rubber matrix. So if we focus on the European perimeter, considering these three feedstocks, we are talking about 2.6 million tons of complex PET waste that could be recycled, leading to obtain a little bit more than 2 million tons of recycled PET. So around 2 million tons coming from the clothing waste. So it's the biggest feedstock. 200,000 tons coming from tires and 10 kilotons from hoses. So the consortium is composed of 16 partners in France, Spain, Germany, Turkey, Norway. So we are you can find waste managers, brand owners, manufacturers. We have universities also working with us for technical subjects, but also to work on the LCC, the LCA, the social impact of the project, and also some partners to work on the dissemination and the communication. I will come back on it just in the next slide. So the project is quite new. It started in July 2022, so it's running since 9 months now, and it will finish in June 2026. So now if we go a little bit more in details of the goals and all the tasks we need to achieve in the project. So first step, we are working on complex waste, as I just said before. So we are 3 brand owners in the consortium, so Michelin for tires, Mandals for lay flat hoses, and Inditex for garments. So the first step of the value chain we want to develop to be able to recycle the PET coming from this complex waste consists to be able to sort and identify the PET contained in this complex waste. So we are working with IRIS in Spain, which is developing technologies to be able to recognize PET in complex garments. And the goal is to be able to plug these technologies on Synergies process. Synergies is a waste manager for garment we are working with. We are also working with Estato, who is managing end-of-life tires to be able also to develop the process. I just come back a few slides before. I forgot to mention something. On the bottom of the slide, in the end of the person, you can see the kind of PET fibers we can obtain when we grind some end-of-life tires. So you can see that you have, of course, PET fibers, but you can see that you have a lot of remaining rubber around these PET fibers. So to be able to recycle the PET, we need to be able to remove this rubber. So to do that, we are working with a P-Prime Institute belonging to the University of Poitiers in France, who is developing an electrostatical method to be able to separate PET fibers from the rubber matrix. So once these very important steps are achieved, the next steps consist to amorphize the PET fibers. So we are working on it with the FTH, the French Institute of Textile in Lyon, in France. And this step is very important to prepare the PET to be compatible with the enzymatic depolymerization process, which is developed by Carbios, French company who is close to Michelin in Clermont-Ferrand. So with this enzymatic depolymerization step, we can obtain PET monomer. Then we need to purify them and then go to the step of repolymerization. And this step we are working on with the DITF, the Institute of Textile Technology and Process Engineering in Germany. Once we will have the repolymerized PET, the goal is to produce new yarns, to make new clothing, new tires, and new hoses. And what is important is to produce these new products with the same quality as the original feedstock. We also work with different partners to develop the LCA, the LCC, to work on the social impact on this closed loop to recycle the PET. So we are working with HVL, the Western Norway University of Applied Science. So for LCA, we are working with iPoint for the LCC and the University of Clermont-Ferrand for the social acceptance. We have Accelera also as partner who help us for the dissemination and the communication of the work done in the consortium, and Dinergy, our partner for the project management. So I propose you to continue to share just a quick video that summarizes the goal of the consortium.
Sebastien, we don't have sounds, unfortunately.
Sebastien,
Sorry.
we do not have the audio, unfortunately.
Sorry, I forgot to share the sound of the video, but it was just music. There is no explanation. Everything is written. Sorry for that.
No problem.
You just missed the music.
So if we focus on our technical activities, the plan of our project is in a few sets of activities. So as Sebastien mentioned, we started in June last year with some preliminary activities about methodologies, about what are the representative waste feedstock we want to recycle, and is it compatible with enzymatic depolymerization. After that first activities, we are in a phase of development of technologies for the three main challenges we have, which are to recognize the chemical composition of complex waste and complex textiles such as multi-layers textiles, coated textiles. How can we assure that we have a part of PET and a great part of PET in a multi-layer textile, and how should we prepare it for the further step? The second real challenge is about the separation, the sorting between fiber and matrix. And as Sebastien said, we are focused in some preparation processes and electrostatic sorting. And then this third part of challenge about the amorphization, which is really needed because of the chemical approach we are using, which is a depolymerization with enzymes, and the enzymes need to cover the polymer, so it must be a low crystallinity polymer, fully amorphized. So we are really in this step, developing the technology, starting from analytical material to real one. And then, starting this summer, we will have a closed loop, a first closed loop at low TRL, because all these processes are under construction. So starting from end of life waste product, so it could be it will be tires, hoses, or multi-layer textile. Use these granulation, recognition, sorting system, shaping system to produce around 1 ton of polymer that should be amorphous, and then to have the depolymerization step to recover the monomers, so terephthalic acid and ethylene glycol. Coming from that monomers, we will have the purification step, and then redo some polymers with the good performances. So we could have polycondensation and then solid state polycondensation with high intrinsec viscosity to have the good molecular weight to be able to reach the specification needed both for technical clothing and also for high performance tires and high performance hoses. For that step, we really need very pure, high quality polyester. So starting from this complex mixed feedstock, it's a real challenge, and that's our aim in the project, is to demonstrate the ability of a closed loop with a so complicated feedstock. As you may know, Carbios is already working with some other feedstock, which could be a clear bottle or dark or color bottle. Here, we want, through this preparation of complex feedstock, make the system to be able to use another feedstock that is already today burned or buried. The main part of composites, textile part of composites or multi-material textile is today buried or burned. So after this demonstration loop, which should be about 15 months of work, we will have an objective of TRL increase on the upper part of our cycle, of our loop. So regarding the complex sorting, textile preparation, amorphization, and also the granulation and fiber matrix sorting, to be able to reach a TRL minimum of 6. And the associated demonstration of efficiencies of that processes. To validate the downstream part of the loop, we will have a trial with quite a huge quantity of depolymerized polyester. So, as I said, Carbios is already working with some PET waste. Here it's a clear bottle, but it could also be a colored bottle. And from that feedstock, we will have about 2 tons of polymer, and we will be able to use industrial processes or pre-industrial processes to demonstrate the ability of this product to be used in very high performances product. On the first loop, we are limited by the quantity, so we will only use prototype processes, not pre-industrial one. That's why we need this second part of loop. After those demonstrations in December 2025, we will have dissemination and so on to go to the end of the project, which should be in June 2026. So as the project ends, the technology will be sufficiently de-risked in the eyes of industries, that the corresponding value chain will become circular within 4 years after the project. That's the aim of our work. And if we go to the first results, regarding the recognition technology for complex textile, we have looked at terahertz and X-ray fluorescence to recognize PET in multi-layers, and we didn't have good performances of those technologies. In fact, we should need another chemical element as a tracer to be able to use one of that techniques. So IRIS is pursuing its work regarding LIPS, so laser-induced breaking spectroscopy and near infrared spectroscopy technologies to see what is the ability of those technologies to recognize PET among a multi-layer product. Are we limited in the number of layers, in the layer thickness to use this technology? Regarding the second challenge, we are working on those sorting technologies from end-of-life tires or end-of-life hoses, and the evaluation of electrostatic sorting is in progress at Preprime Institute. We are working on the ability to separate what is the purity of the fiber we can recover, starting from the picture at the right part of the slide. And another question is, what is the efficiency of the process? We will conclude in a few months on that. On the amorphization step, we are focusing on two technologies that are studied. One is about the PET extrusion. So we are going to use to melt it and then use a cold to cold the system to have an amorphous structure. And another one is the use of plasma. And in that case also the evaluation is in progress to define what is the more suitable, both technically but also regarding the energy use to have this amorphous PET. Because as Sebastien said, we will have this life cycle and assessment of all the closed loop, and that is key to have the more environmental efficient process to be able to really propose a solution that is good for the environment. Finally, regarding the depolymerization, the first trials with analytical samples are encouraging. They are made at lab scale at Carbios, and in the next quarter, we will have some trials with more real samples, so with extra materials. So it could be another kind of fiber or some remaining coatings or remaining elastomers. So we'll have this residue, and we will define if the depolymerization is still at the same level of efficiency. So that was first technical progress more than results, because we are at the starting point of our project.
So we should have more results, more relevant results during the second part of the year on this very challenging part of the project. So just to finish, I take the opportunity of this webinar today to talk about our first dissemination workshop we will organize in November here where we are today with Christophe at Michelin R&D Center in Clermont-Ferrand. So we are at the moment working on the potential subject for the roundtable we will organize. So we see two kinds of subjects, if I could say. One more on the technology side, as you have seen for our project, the waste collect, the sorting technology, the identification of the waste to be able to recognize the PET in complex garment is very important for us. And also, we would be also very interesting to have some co-working session of the management of the waste, the social acceptance also of the circular loop we want to put in place, and of course, as we said, LCA will be very important. As you see, the many steps we need to put in place to have this closed loop to be able to recycle the PET from complex waste. So sharing best practice for LCA would be also important. So I join what you said, Marisa, just before for the Align project. So now you have more elements of WhiteCycle project. You know it a little bit better. So if you have a question or if you think you can help us and want to join us for this dissemination workshop, don't hesitate to contact us. And I just realized that I forgot to mention our partner Corsa during the presentation, who is a provider of yarn for our tires. Thank you for your attention.
Wonderful. Thank you so much, Sebastien and Christophe. And indeed, if you have any questions, please don't hesitate to write it in the chat for the WhiteCycle project as well. And as mentioned as well, this is a project that we run for 3 more years. So definitely we are going to be looking forward to hear about further developments and results in future ECOSYSTEX webinars. And with that, I would like to move on.
Thank you.
Thank you. Thank you so much, Sebastien. So with that, I would like to move on to our last speaker of today, introducing a new developments of the HereWear project. So I invite Becky Earley from the University of the Arts, London. Becky, please take the stage and share your screen.
Hello, welcome everyone. Thank you very much for having me today. Now, hopefully you'll be able to see my slides. Let me just go to full screen. All good?
All good indeed. Thank you.
Thank you. My name's Professor Becky Earley. I'm based at the University of the Arts, London, in the Centre for Circular Design. And today I'm going to be presenting the BioTEN, which is one of the first outcomes from the HereWear project. And I'm going to give you a real overview to this framework, which has been built to inspire and guide all kinds of design stakeholders in the emergent bio-based fashion system in the EU. So I'm going to give you a quick overview of the project and the project partners and talk a little bit about how we're working with design in this collaborative context. And then take a quick look at the kind of sustainability guidelines that are already out there and the rationale behind developing this new framework. And then we're going to look at the framework and how we built it using a bio-based materials archive before finally presenting the sort of the 10 principles that are at the heart of this framework. So the HereWear project, if you haven't heard about it already, it started in October 2020, and it's coordinated by Guy Boyle at Textile in Belgium. I think Guy might be on the call. And it involves other partners that have actually been mentioned today as well, including DITF, as well as RISE in Sweden, TNO, Mertec, Finiper, Mitwell, Retina. So we're actually working with many brands as well. University of the Arts, London, Eurocat in Spain, Circular Fashion in Berlin, MyBean, Romania, Sketch also in Berlin, and the TCBL network, which is a really big network of SME fashion and textile companies across Europe, as well as Queen of Raw. So it's a really great group of collaborators, which is incredibly important, as what we're trying to do is create design guidelines for all kinds of design stakeholders in the supply chain. This quote from the Textile Exchange sums it up rather well. To enable the responsible adoption and proliferation of biosynthetics, a collaboration of various stakeholders is required to address these challenges and concerns. So we're really trying to understand, first of all, the information that we need to share, and to whom, and in what format. So really understanding what decisions are made by which stakeholders, and all really in order to try to build, promote, and use new bio-based materials in the best possible, most appropriate way. I'll read a little text here about the HereWear project, just to give you the more detail around the whole picture. So the HereWear project is building a holistic systems approach towards the creation of an EU market for locally produced textiles and clothing made from bio-based resources. New material solutions have been building on the latest bio-based polyesters and cellulose developments, exploring 3 novel waste streams: seaweed, manure and straw, for making cellulosic textile fibres. Working in tandem with technical material research actions, design and manufacturing is being explored via the creation of garment prototypes for streetwear and corporate clothing. The use phase and end-of-life processing management, so the use, the reuse, the repair and the recycling elements, is also being explored to understand how new design approaches and business models might support this. So the interesting thing, I think, is that we're not only looking at the waste materials, the raw waste that's being used to create new bio-based materials, but we're also looking at the kinds of garments, so the kinds of textile, the kinds of finish, the kind of design, the kind of function of the garment, and then how it's used, reused, repaired, remade and recycled before it then goes into material level, fiber level reprocessing. So it really requires quite a different design approach from the outset. There have been many design guidelines available over the years, and it's really important that they speak the language of the designer. Some research estimates that it's designers that make up to 80 to 90% of the decisions that create the product's footprint. So for a while, designers have been made aware of their decision-making processes through different kinds of guidelines. And these are often evaluated and tested in different ways, some being more effective than others. And it's true to say that the kinds of frameworks which have a more holistic approach, so looking at all the decisions, all the creative decisions that might go into making these kinds of clothes, not just the product design, but the communications and the sort of advertising and the language that might go with such new products is really important as well. So we're taking this holistic framework through into the design guidelines. The main remit is that we need to make guidelines specific to bio-based materials. They need to be made, making products that can fit with circular systems and circular loops. And we need to be considering the local context. What does that really mean? What does that really look like? What does local clothing used by local people and recycled and reused locally actually look like? And how can we encourage these practices? I'm sure I don't have to give you the statistics. You just need to look at the work of people like Walter Stahl to understand that if we're going to have circularity working effectively, we're going to need to keep the loops small as possible, so that we're reducing transportation as much as possible. So the framework covers design for circular, local and less, as well as design for circular life cycle extension and design for circular behaviour change. So those are the sort of 3 main principles. But before we get there, I just want to quickly sort of talk about the route to getting to the principles. We went about collecting as many bio-based materials as possible. To speak a designer's language with guidelines, you have to think about how they work and how they make decisions. And they don't start a design process by reading guidelines. They start a design process by having an aesthetic sort of desire, a desire to see something created, a response to the moment, the zeitgeist, colour, texture, feel, cut, pattern, things that are responding to the issues of the moment. So it often starts by choosing the materials that evoke these sensations. So starting with materials was really important to us as a methodology. And we collected over 100 bio-based materials, which we then also categorized now, near and far. So which of these bio-based materials are available and can be ordered and used, which ones are being developed and will be soon made available, and which ones are more far future. And this is really important because we have to educate designers on what's coming next, and what they can expect and what they can anticipate working with, as well as what can be made available right now. This also gives us a framework and a baseline of materials to develop the new materials in the consortium with as well. And then we developed this unique material wheel to show, when we took each sample, how it had been made in the first place. So what was the original feedstock? What had happened to that feedstock? What had happened through the next stages of filament, yarn, textile, fabric, before it was then in a design process, a garment design process and production, and then through various uses before it went to an end of life route. One of the reasons that we wanted to be very clear from material to material was to help designers really understand what was bio-based, what it meant, how processing in between might affect the recyclability, and what suitable end of life routes should be specified and designed for. So in order to get going with the designers, with this sort of knowledge behind us, we were then able to introduce this framework and essentially lay case studies in front of designers to inspire them to either change an existing design, so redesign, or come up with a new idea inspired by a case study. So some of the principles then that we're looking at within these three frameworks. The first of the sections is designing for circular, local and less. And this is really about selecting bio-based materials according to their end-of-life trajectory. So thinking about circularity first and foremost. So the first question being, how can this be recycled? Production and waste reduction decisions along the way, and therefore the textile selection. So often what we're trying to do is understand how designers need to work for circularity and change the order of the decisions that they might be taught in traditional fashion or textile schools to make. So it's a sort of reversal of the decision making. So the first decision, the first of the BioTEN, is designing for recycling, understanding the end of life trajectory, cyclability. So basically, what is it that you might do that might inhibit recycling? And then also designing for donating, collecting and sorting, which up until recently had seen very little innovation. BioTEN 2, design for production. How can we choose and make decisions about local production and making it ethical and sustainable too? Number 3 is designing to minimize impact. And this is all about the decisions that go into selecting and then the finishing and embellishing of materials. So don't forget, as soon as you want to make something shiny and a designer will put a PVC coating on, we're instantly affecting the life cycle impact and the end of life trajectories. So it's really important that designers start to develop ways to create aesthetic finishes that are less harmful. BioTEN 4 is designed to minimize waste. And this is where we're looking at what some research says is up to 23% of all fabric globally that's produced annually. 23% is never used, whether that's through factory floor cutting waste, or damaged stock, or stock that gets ordered and made and then cancelled and never used and often incinerated. This is a huge problem, and 23% of global production is a huge volume. So designing for circular life cycle extension is our second theme. And this is ensuring that the bio-based materials and products that are designing are as durable and long-lasting as possible. So this is in alignment with principles, of course, from the Ellen MacArthur Foundation and cradle-to-cradle thinking more broadly, that the things that we're making need to last as long as possible. And this is tricky with fashion because often it's the look or the style that will date before the actual durability of the materials. So we have to build in adaptability. So BioTEN number 5, design for durability, and that's thinking about the physical durability, the aesthetic and the emotional durability. And they're all three quite different things. Physical being obviously the strength of the garment. Often that's something like the tightness of a weave can actually add really good physical strength, but also the kind of strength of the seams and how they are sewn and finished. Aesthetic durability is a bit like classics. Think of a striped Breton jumper, things that actually don't date, that are constantly appealing to people. Very hard to really design for, especially with the way in which our generation X's, Z's, Y's are changing so rapidly these days. But there are still very classic styles out there that we can draw on. And then emotional durability, this rather nebulous idea of all the things that we hold on to for a really long time because they mean something to us. Something that designers have really been trying to work with ever since Jonathan Chapman wrote Design for Durability, design for our emotional durability. It's really hard to design for because it's very, very, very subjective. Often it's my grandmother gave it to me, so that's very hard to design for. But we're also in design for durability talking about washability. So that's how well things wear through different laundry cycles. Wearability, and that's really about, does the thing I've bought feel nice, sit well on my body, make me look good? Is it good for wearing? And repairability. Has the designer thought in advance about where damage might occur and anticipated that and designed around it? BioTEN 6 is designed for change. So can the designer build in the opportunity for customization, multifunction, adaptability and modularity? And again, they're all quite different things. Customization is where we give the customer the opportunity to adapt a garment and make it their own. Multifunction is a garment that performs in different ways when we've got it. So you can zip off a pair of trouser legs below the knee and have a pair of shorts from the same pair of trousers. Adaptability means that you're making something that you know will be changed in the future more permanently. So often with adaptability, you can't go back to the original form. Maybe it comes with care instructions that say that you can chop off the sleeve and turn a long sleeve tube dress into a sleeveless tube dress. Modularity is where we actually can change the look of a garment by adding in pieces. So you might be able to add on a collar, and then that collar might change with fashion from long spiky 1970s or 60s collars to big round 70s one to tiny stand-up collars. You know, modularity are all the pieces that you might add to a garment. BioTEN number 6 then is designing for, oh, I've done that one. BioTEN number 7 is designed for sharing. Now this is a really hot area in terms of the economy at the moment. Rentability, swappability. Really understanding how designing the fibre, the materials, the product will change when we are making products that are likely to end up in a library, in a fashion library, or changing hands through swapping, peer-to-peer. But of course, now we've got businesses that intervene in that route. But also designing for sharing is about returning products and there being business models and sort of functions in the product which enable it to be easily returned and then resold. And again, that's another real hot topic at the moment because many returns actually don't make it back onto the shop floor. Again, they might be incinerated rather than pay the price to clean, repackage, relabel and rehang. BioTEN number 8 is designed for upcycling. And this is where you anticipate that the product you're making at the beginning will later be remade and remanufactured. So really, we're trying to understand how we must design so that we can enable those kind of activities later on. An example might be putting something like a vinyl sticker sort of transfer on a t-shirt means that we're stopping the cyclability later on and we're stopping the sort of the change of the aesthetic of the product. So we really need to think about how we can design things that are intended to be remade. And then the third section, then designing for circular behavior change. This is where we're really trying to understand how this initial work by the designers can be better communicated and coordinated across the departments in a company. So quite often you'll have an eco-design project or a circular design project happening in the design team, not even in the whole design department, but sometimes a very small specialized group that have been selected to do new product development. And all the ideas and all the knowledge and all of the sort of real wealth of thinking exists within a really sort of small siloed area. So we're trying to, with these strategies, actually encourage the whole process to be more incorporating the other areas and the other activities so that more people are aware of the intentions and the needs around circularity and the core messages of the product. Especially as so much of circular products need the customer to participate in one way or another. It means that marketing and communication is much more crucial than any other time before. We need to be putting products out there with people not only understanding what needs to happen, but actually being excited about the fact that they've got a circular product that can work in a different way. So we're really looking at design for communication and design for collaboration here as being very much part of the product development phase. And this is quite untraditional. This is not what happens in industry unless you're in a very small company and you're creative director and you're in charge of all of the creative decisions going on. This is very much sort of separate activities at the moment. But by developing products for the circular economy, we're often bringing stakeholders together. So we often need to understand what kind of communication needs to happen both internally in the company and externally to the customers. So this is about messaging around reducing, respecting, and then the labeling and the marketing and the activism that any company might invest in and really try to sort of be better at. I think many companies have got a long way to go with these ideas. And then design for collaboration. And for this, this is sort of the most far-reaching, far-thinking design strategy, because it's very much about looking at the way in which a traditional designer and company works and seeing themselves as part of a system rather than a singular entity operating with its own business model. It's much more about seeing the ecosystem of businesses. And within that, really all of the methods for using these strategies sit. I have more slides, which are examples of each of the 10, but I'm pretty sure I've probably used my time up and I want to make sure there's time for discussion and questions. So I might just leave that there.
Actually, Becky, we were running a little bit ahead, so you definitely have more time. So until past, to be honest, it's still 15 minutes if you like, feel free.
Okay, if that's all right with everybody, I'm very, very happy to carry on. Okay, so it often helps with designers to see an example of how the thinking's already been applied. And it's only then that they really get this. It's all very well writing it in words and giving it a framework and even writing the reports that go with our projects, which we must do, of course. But designers are visual thinkers. You might know about the left side and the right side of the brain. It's only really all the creative people, you know, tend to want to go into art schools and learn to be designers or artists. Their brains work very, very differently from other fields. We don't know very much about this, but what we do know as tutors in design schools is that designers only really get things when we show them images, and their visual data then sort of grows inside their heads, and they begin to sort of piece together different things that they've seen in the past, and in that way they make their own designs. So when we've built the framework, we then find case studies and put them into this framework, and then for any sort of use of this toolbox, we will start by showing a set of case studies. From that, after that, we would then have a workshop format which would help them to do the designing themselves. So an example of design for recycling we've taken from the Trash to Cash project, which was a project I worked on, I think, between 2015 and 2018, that used cellulose recycling of waste cotton. And we, for this particular product, kept in the blue colour of the waste cotton. So we're really thinking right at the beginning with this product of where this supply of waste textile is coming from, and then what we do to it in order to make the next stage so that we don't inhibit its recycling later on. So the whole of this process was about making a recyclable, recycled shirt. And with that brief in mind, we worked out that to keep the footprint low, we could actually keep the original blue colour in there. So rather than bleaching back to optical white, we were trying to design a process and a system that worked with the blue dyes. So with these examples that we show designers as part of this BioTEN framework, we'll often tell people, again, if it's now, near or far. I've actually taken off those stamps for this talk because I didn't want to get over complicated, but it's really important that people, the designers that we're working with, understand if something is research and an idea, or if something is in development and closer to market, or if something can be bought and actioned right now. So with every case study for this particular project, we're stamping on the left-hand side, you can see whether it's bio, whether it's circular, and whether it's local. And then we would often give it a timestamp as well. And what's been very interesting with this process for us is that when we're stamping down the left, we can actually start to see the gaps in the market. So if we can't find an example that lights up all three of those elements, we know that something is missing from the market. You'll see that in a second. So for this, for example, design for production. With this garment, we're actually looking at an example of a bio-based circular fashion textile product that's been made with the welfare of the planet and local environment as its first priority. So this is where the entire supply chain changes to be as earth-centric as possible. And the best example we can find of this is carbon negative wool. So as you know, with the emergence of regenerative farming and some key carbon offsetting approaches, various companies actually, not just Sheep Inc., but also Allbirds, trainers, are now making products which claim to have a carbon negative impact. And given the LCA presentation before this, I'm sure that could be hotly debated. But it is the ambition to make fashion ultimately that is good for the planet. It's a very interesting area, and I think really commendable, and builds on ideas from a book called Earth Logic by Kate Fletcher and Matilda Tam, which is really worth looking at. But you'll be able to see then that what we've got on the left-hand side is this innovative product, but they're not specifying the end-of-life route for wool. And wool is an area which is really interesting for recycling. And of course, Prato in Italy has a huge history of this, but it's not undergoing huge investment at the moment. So this particular company are not asking customers to bring the product back to them, and they're not offering to deal with that cycle themselves. So that's why it's not got the circular bar lit up. So therefore, we would be able to say to designers, can you work on a project? Can you evolve an idea which would be carbon negative, but also circular? So then design to minimize waste. This is where we're looking at a fashion product that's been designed to reduce material resource use through the use of fabric waste. So basically everything is made from waste. Really common approach amongst SMEs, really common approach amongst students, and has been so for years and years, primarily driven by cost, but actually now driven by sustainability issues. And finally, coolness. It's finally cool to have the remade products. So for this, we put an example together which was made in Hong Kong from local waste for a local consumer, and is recycling waste materials, both old post-consumer materials and parts of pre-consumer waste as well that was also found on site. However, it's not using innovative bio-based materials, and therefore on the left-hand side, you can see that that's not lit up. So again, that's like a traffic light. It's like an indicator to the designers we work with that there's an opportunity there for them to fill that gap. Design to minimize impacts. There's a whole wealth of new finishes out there that designers can draw upon. Waterproofing is always a really good example that's been undergoing quite a lot of legislation and chemical restrictions in the last few years. But so for number 4, this is an example of a fashion textile product that has been designed to minimize impacts through better finishing processes. So this is Dimpora's Sane membrane. And I'll just read this for you. Going one step further from EcoPur, Sane membranes process allows the use of biodegradable polymers right away. The template removed from the membrane allows it to breathe while the rain is kept outside due to the internal functionalization. The membrane is one part of a biodegradable laminate with fabric and adhesive. After the lifetime of the product, it can be directly returned to nature without leaving a trace. So for this, it's bio-based, and they've also thought about the circularity. But the researcher put this together, said that it's not being produced in a local context. This is using a traditional linear wide supply chain. So again, you can see there that we're hinting to the designers what they might do based on this case study. Design for durability, lots of really nice examples, because the idea of making clothes that last a long time is really appealing to fashion designers. They don't want their work to be ephemeral and just disappear. Ultimately, designers want their work to be meaningful and last. So lots of brands can be found that are making higher quality clothing, more classic clothing. But as you see on the left-hand side, then often, less often in a local context, still using traditional manufacturing routes. So Eileen Fisher is a really nice example of a very classic, clean, simple wardrobe. Of course, the problem with this is price point. To get that long life material and to get that classic finish, that means good quality textile manufacture and good quality tailoring. And so therefore the price point when you have durability is often much higher, which does leave a question about the volumes that this can apply for, because so much of the market is the lower end of the income bracket, the lower end of the scale. Design for change, lots of nice examples out there for how designers are now working with products that can be customized and basically give the consumer the choice of having a product that's more adaptable to different circumstances. So the idea of, from a sustainability point of view, this only works if you're really replacing things. So instead of having 3 or 2 different shoes, you would have 1 pair of shoes and replace the uppers. And it's really, this has been happening for quite a number of years. And I think the alignment with sustainability is still some way off, but it's interesting in shoes because shoes have still got a real challenge to become circular. Design for sharing then, and this is an example of mine where I made a garment that's specifically made to belong to an owner at the beginning, but then be customized and then go into a sharing library and then go into the lining of a jacket and then jewelry and then chemical recycling. And this meant that as a designer, I had to explore the methods hands-on, and then I could write more guidelines about how specifically you design something to last a long time. There's various articles I've published about this, but it really is a very sort of different set of decisions, particularly with this product where it's overprinted. So you're basically bringing a garment back into ownership of the brand or into a parallel company owned by the brand or a partnership of the brand, and you've got an aesthetic plan for it to change looks over time. So you're actually, as a designer, designing the change at the beginning. Design for upcycling then, and this is really about understanding, again, much more about these sets of decisions that you have to make when you're designing with old materials. So you have to have a sensibility about a material, a textile type, its weight, its cut, its feel against the skin, its function in the elements, to really then know what kind of product it should go into. So we're sort of talking about this by calling it design for upcycling, where you're designing the first product and you're understanding that it's eventually going to be remade into something else. There's a really nice example, actually, we haven't got it in the deck, but where curtains are produced, and then when the curtains are at their end of life, you remove the lining, and printed on the inside of the curtains is a plan, a lay plan for you to cut and then make clothes from the curtains. So actually they're practices that went on historically, but designers are drawing back on those ideas now and putting them out in contemporary products. So then the last two, a design for circular behaviours, and we're talking about how we can design for communication and how we can design for collaboration. And this is a really nice example whereby Olivia Firth set up an app and a 30 Wears challenge. So Olivia worked with sort of fashion and textiles and eco design and an agency and advised all kinds of brands. And then she really realized that what was needed was a way to help consumers wear what they've already got a lot more often and be a lot more creative about how they wear things. So she developed this app which helps people track the wears and then celebrates when they reach 30 wears. So it's really trying to sort of like get the design thinking that's gone on with fashion creatives into the communications field to bridge that gap between the product and the user and encourage better behaviours. And then this design for collaboration, lots of things we could have showed here, but we show Ivan for being very inspirational with a completely different mindset. So the CEO of Patagonia, you know, basically gave over the ownership of his company to charities fighting climate change. So rather than, you know, pay the money back into the shareholders' pocket, he's basically taking it a step further and saying, well, I love this company. People love my clothes. We all love the planet. Why don't we try a different business model, a different mindset around businesses? And on that note, at 10:30, 11:30 your time, I will stop sharing.
Perfect. Thank you so much, Becky, for introducing BioTEN and also for the very, very good use of our extra 15 minutes. It's really interesting to see the examples. And I would like to invite everyone, of course, once again, to address any questions to Becky in the chat first. And we are going to move now to the Q&A part of this webinar. So we are going to finally take each question in the chat, invite the speakers back, and we are going to address them. And this part will be coordinated by one of the key facilitators of ECOSYSTEX and also the Secretary General of the Textile ETP, Lutz Walter. So I would like to invite you, Lutz, to take over for the Q&A. Thank you.
Thank you very much, Camilla. Hello to everybody. And first of all, many thanks also from my side for the excellent presentations from our, well, 4 speakers actually. Oh, we have 5, even better. Good. And well, I think we have a few questions. I put a few questions in the chat. It was basically, I thought, well, I could write them down here on a notepad, but I could way as well put them in the chat so I don't forget them. So also as a way for the speakers to maybe already have a look at them and prepare, let's say, an answer if they can. So I suggest we go by the order of the presentation as we saw them. So maybe starting with the Aligned project and BTG. Well, there were 2 questions I had there, but maybe also a few quick ones also from other people. But maybe to keep it structured, I'll go in the order in which they appear in the chat. So the first one was indeed from me. A lot of the greenhouse gas footprint or the environmental footprint of a textile product in its entire life cycle actually comes from the actual production stage. So basically from the spinning, weaving, knitting, whatever you have, and especially the finishing, garment making less so. That represents about 60 to 65% of an average garment's footprint. And a lot of that is actually energy. So the CO2 intensity of energy is actually a very, very important factor. That and I wonder to what extent that you look at that plays a role in your LCA and well, how you think about it in general.
Thank you for this great question. I think it's definitely covered in the LCA. I believe it is one of the main impact categories of the LCA itself. So the LCA will look at the share of renewable energy and the energy mix itself, and then the impacts to generate this electricity. So the CO2 intensity, I believe it should be covered as well. Yeah.
All across the value chain,
yeah.
Of course. Yeah. But indeed, what you say is true, that it's indeed mostly the production. Then the point where you can really improve the environmental sustainability will be there. So we try to focus on the things which have a big impact.
Yeah. And these things are sometimes not as easy to influence. That's why I think a lot of companies today, especially in the fashion sector, they focus more on the material, because materials in a way are more easy to swap. Let's say, well, you can replace a conventional cotton by a certified organic or whatever, assuming that the impact is better, but you basically have the same physical material, so it's very easy. Whereas if you want to change a production process from gas to electric, that's a lot harder to do. Or moving from a production location which uses whatever coal-based energy to a production location which uses renewable energy, again, may not be as easy to do. So that's why I think sometimes the focus of the industry is where, well, sort of the low-hanging fruit, but not necessarily the most impactful ones.
Yep, you have a very good point.
Yeah. There was a very practical, quick one. You mentioned your consultation, the online consultation. Yes. What's the deadline for it for people who want to react?
It should be open for another 2 weeks or so. So let's say the middle of April.
Okay, good. Well, we'll share it, and but if you have a moment today, do it right away. So it's done. So you won't miss the deadline. Then going down here, yes, there was another question you mentioned initially. Also, you talked a bit about the impact and the growth of fiber consumption, how it is tracking to population growth and so on, and the growth in synthetics. You talk a lot about fashion, but we know we use a lot of textile fibers for applications that have actually nothing to do with fashion and clothing. Nobody knows the exact figure, but best estimates is that it's beyond 50%. And that, I think, is also the part that is very much more difficult to rein in some way. Because yes, we can say we may be able to get off the sort of the fast fashion cycles, but we use, if you just look at, well, you look at hospital clothing, we look at an aging society. In many countries, we sell more adult diapers than baby diapers these days, which are also made of textile fibers. So these are volumes that will certainly grow on a global scale. And I think there is also where the move to bio-based is very, very important, because I think that we won't reduce the volumes, but at least we will not take as much fossil fuel from the ground anymore. How do you view that?
I think you have a great point again. So with the case study, we are really focusing on this work clothing. But for the rest of the project, we are also covering some non-garment textiles as well. So maybe we're not as focused on them, but at least myself, I am working on gathering information about the sector. So to give a great overview of the sector, and this is definitely covered in there as well.
Yeah. And thank you for mentioning this. This is helpful. Yes.
I see Becky maybe wants to react immediately to that discussion too.
Yes, thank you. I put my hand up. It was just really a comment because I've worked with polyester for a long time. And I suppose my sort of question is about, you know, this idea that if we stop using synthetics, we'll leave oil in the ground, which as far as I've understood is just not at all what will ever happen, because we're using the byproduct of the petroleum industry to make synthetic materials. The parts that can't be used for fuel, for transportation, are used to make synthetics. So isn't the question about when we stop using fossil fuels for transportation, because it's always going to be available and it's always going to be cheap, and we're always therefore going to be pushing against this massive economic juggernaut. So I know we're the research end of things and we've got to make the future models that are available for take up and ready to go. But I do find some of the language on this discussion around bio-based replacing fossils to be skewed sometimes when, you know, it's such a big consideration, how the synthetics aligns with transportation.
And maybe I can say something about it. I worked in this in the energy business for quite a long time, and when I started, we talked about niche development of renewable energy. It's never going to be big. It's going to be 1-2% maximum. That would be wonderful. It was called alternative energy then, because it wasn't real energy. And in the course of my work, this has changed. And it has changed actually substantial. And now we are talking about net zero in 2050. Substantial renewable energy forms, renewable energy production, solar, wind, hydro, geothermal, etc. And transportation fuels are the next ones. It's not even a huge amount of energy if you look at the total energy, but already the development is underway to also make that more sustainable. And synthetic fibers, the bio-based production of those, the technical challenges are certainly there, but so far none of those seem to be completely insurmountable. So I think on the back of transportation, also all these fibers can be made from bio-based materials, maybe even other renewable carbon materials. So I'm actually quite optimistic about that. It won't happen today, maybe not tomorrow, but we are on that path.
That's really good to hear. Thank you.
No, I think that was a very important point to say that these are all very complex systems and very large scale systems. And there isn't just a polyester industry that is just taking oil from the ground and turns it into polyester. It's a very, very complex petrochemical processing industry that makes all sorts of byproducts and intermediates and all these kind of things. And they all somehow link together, and they cannot shift from within a year, within 5 years, within 10 years. It will be always I think a slow mix shift, probably. That's what we are looking at. And where it makes sense, bio-based will come in, and where it makes sense, recycled will come in. And for many things, we will use virgin materials still for a long time. And if we make that use as durable and as efficient as possible, well, then even that, I think, is not the worst in the world, probably.
I think that's a great comment, Lutz, and it's the first time. You don't often hear about this portfolio of solutions and where it's most likely to be the best answers. I think that's a real point for further clarification and mapping, really, because that's, as a designer, that's the way I see it, that we need so many different things. It's not one thing instead of another, and every product has a very different use and specification. And I think we need more, not truth, but more alignment. I think it's called design for appropriateness. There just needs to be more information rather than a generic broad brush. We can make clothes with this. It's kind of like, can we though?
We can, but
yeah. But will we? Yeah.
All right. Okay. Well, let's move on. We have still a question for Marisa. The scope of your LCA, cradle to cradle.
Yes, as we're going over the entire recycling process as well, it's important to take into account the entire life cycle of the product. Yeah. Yeah.
Okay. Clear answer. All right. Then let's move on to the WhiteCycle team. First question, I think people are interested in the workshop in November. I guess you will share more information as we get closer to it. That's one of the things we want to do with the ECOSYSTEX initiative, is to share information about those events that are public, that are accessible, that the various partner projects organizes, so that more people who are interested can learn about it. So we will, as one of our activities, we will create this joint dissemination working group, where then we will probably collect a calendar of events from the various projects, share that so that people can find it. But maybe Sebastien wants to say something more about the event you're planning.
I'm glad to see that some of you are interested with our workshop. So you can directly send me a mail to discuss about it to me and Christophe. And we will have our next steering committee beginning of June. During this steering committee, we will choose the subject we will choose for the roundtables. And of course, we will communicate about them on social networks. But to start, don't hesitate to directly contact us, by mail.
Perfect. Okay, and then I put a few questions there as well, more technical nature. So what does recycling of tires today look like? What are we talking about in volumes, especially when you think about what's the percentage of, or the weight maybe of PET material in a single tire? Because that's, again, what I mentioned before, there's so many users of textiles that are not linked to fashion in any way. And I think the car industry is a significant user of textile fibers. And well, when it comes to recycling of textiles used, let's say interior textiles and so on in cars, I think right now we look at basically 100% incineration, because the recycling targets are basically mostly focusing on weight, which are mostly metals. But how is it for tires? What's the situation?
Just a first point is, if we look at the total environmental impact of tires, the main impact is during the use of the tire.
Of course.
So we all, you may know that there is a rolling resistance, which is a measure of the quantity of energy loss when the tire is rolling. And Michelin started more than 30 years to work on that. And what we are doing on end of life and also the choice of our raw material is very important, but we can't reduce the performance in rolling resistance, because it's the key impact we have, and also to have a long life products. It was said also in some other presentations. We have to keep in mind those two elements to keep a good, to have an environmental impact which is better than today. But if we look at the recycling processes, in fact, in 1999, there was a EU regulation to avoid landfilling of tires. And starting from that point, all the tire manufacturers try to start to work together to be proactive, and we developed some associations such as Aliapur in France, but there is in lots of various countries in Europe to recover the maximum number of tires. And today it's about more than 80% of tires that are recovered. And then, so there is an eco tax. Each time a tire manufacturer sells a tire, he pays an eco tax, and this eco tax serves to recover the tire and also find a way to use these end-of-life tires. Today, from 100 tires, about 14 are reused. So it could be through retreating or another way to reuse directly as a tire. 50% is energy recovery, and about 35% is material recovery. And surely to have a better environmental impact, we want to increase this material recovery, and that's one of the objective of WhiteCycle. If we look at a tire, for passenger car tires, which is around 8 to 10 kilograms, there is between 5 to 10% of PET fibers. So it's quite low. We are dealing with maybe 300, 500 grams in these tires. But the chance we have is already all these tires are recovered, and they are, for the material use, they are granulated. And the elastomeric part is reused for various, for example, for soil or for vibration insulation or so on. And in fact, there is about 20% of these granulated tires that is not used because it contains fibers, and there is today no way to reuse that, and that's our feedstock. So our feedstock is about 20% of these granulated tires, and among this there is less than 50% of polyester. That's why it's a key challenge to sort, to maximize the quantity of PET in the waste, to be able to have an efficient depolymerization step.
And even if the quantity of PET is quite low, as you said, Christophe, in one tire, we know that we have a huge number of tires rolling across the world, so it's a big feedstock.
In total, it's still quite a big amount, yeah.
And what we hope is developing these processes will able to reuse also the polyester in other composites, elastomeric composites or other composites, and it could be introduced in the same loop of recycling.
Yeah. Okay, thank you. There are two more questions to WhiteCycle, which are somehow, I would say, probably related more to the probably the clothing side of things that you also deal with. One was relating to buttons, which are often obviously an accessory of clothing, like other sort of hard parts that you find in clothing. So is there a chance that these could be recycled together at the same time? So not probably being removed in the process first.
Yeah, sure.
And also the question that came from Textile, if there's a minimal percentage of PET required in complex textile, I suppose it refers to the recycling process here.
So regarding the buttons, in fact, today we start after the removing of the hard points. So after the removing of buttons and zip and so on, because we want to develop a system to amorphize and so on, starting from fibers, not from higher
compact and
yeah, more compact, more dense product. So but tomorrow, if we can select polyester button, I don't know what is the part of polyester button in the total amount of buttons, it could also be considered. But today it's not in our project frame.
It won't be compatible with the first part of the closed loop of the project, but perhaps it could be something that could be developed to make it compatible with the enzymatic depolymerization and reuse after.
And I think it could link back to the design aspect that Becky was talking about. So if we can design sort of products that are monomaterial, even if those monomaterials could have a very different function. So if a button and the textile product to which it is attached is the same chemical material, then that could have a recycling advantage, and that could make sense. So that's clear. Yes, and then I think, yes, Textile had a few follow-up questions specifically. I think it's specifically to the recycling process. So what purity, in a certain sense, you need on the polyester side to have really a recycling process that works efficiently. So what high level of purity is needed? So because obviously often you have contaminations or you have blends and mixes with fibers and other material. Polyester fibers and other materials.
Yes, that's true. So our target is to reach 80% of PET in the feedstock to have a, how could I say, efficient process with enzymatic depolymerization. And for the first part, it will depend on the performance of the sorting and the recognition technology, to be able to identify the PET, increase the percentage of PET in the selected garments.
Because as you said, if we have this enzymatic depolymerization with more than 50, more than 20, we fix, but even if it's 50% of mass that is not polyester, it will we will have something which won't be efficient enough. It will be costly and also environmentally not so good.
It will be also, I think, an important part of the economical study, impact study, to give these figures.
Okay, thank you. Okay, then I would say we move on. We have at least one clear question to Becky here. How beneficial would it be for designers to have access to a platform with sustainable suppliers, with the LCA report, also regarding social aspects? And I think that's something that also reflects a bit of question I had to you, which is to say, well, you said it very clearly, designers work on often on a very visual, a very emotional basis. And how can we feed in sort of the more technical, the more sort of sound sustainability information and data into that process so that is easily usable, easily picked up by designers. And I think that relates also to that question of having a platform or tools or something like that that designers could easily work with.
Yeah, the word easily is just never going to be used, really. It's so difficult because for many reasons, the way that designers are traditionally being trained means that they don't get open to this information at the early stages when they should, really. But people struggle to understand life cycle tools, assessment tools in design schools. So there has been efforts to try to sort of bridge this and make it simpler. But even tools like the Higg Index often get assigned to a specific person in the company who then does assessments after things have been designed. Whereas, of course, we're trying to get it involved earlier on. Yeah. So part of the work in the HereWear project, which actually was really explored through Mistra Future Fashion over quite a long period, was how to bring in decision-making moments in collaboration with LCA experts. So tools are being developed which, you know, you can basically say, right, I want to make a pair of jeans, which material, click, you know, and you're sort of building a picture as you go along. So it's sort of in development, it's slow, and we're finding lots of problems with agreement around what data is suitable for use, from, you know, because it's just so nefarious, really. Yeah. But in terms of sourcing materials, so you've got organizations, platforms exist like Common Objective, and also specialist sustainable textile fairs, like the Future Fabrics Expo, which happens 2 or 3 times a year. But whilst they offer a limited amount of information as to why is this better, they don't have the expertise to then show any kind of evaluation and assessments. Yeah. So it's continually finding a way to bridge these areas of information and find this point of that where it could be platformed and presented together. We also know as soon as you might have achieved that, it would be outdated really, really quickly. Yeah. So how do you actually build that kind of framework, which is really sophisticated, and then keep it updated? One of the ways that I think the industry has realised is you have to take it product by product. So the work the Ellen MacArthur Foundation did around jeans was really excellent for that, because over 100 pairs of jeans were made by different companies, and then they pooled and shared the data and information. So you have this really rich picture and understanding then about all the different ways you might make a pair of jeans. Yeah. But no simple answer other than building new areas of practice which bridges the knowledge which we know is out there, but bearing in mind that even that knowledge we know is not sufficiently realised yet. We're trying to build a social LCA model in the HereWear project as well, and it's really complicated.
And it's so subjective to the use case as well. This is also, I think that shows where the limitation in all of that is. If I buy a perfectly organic, recyclable, locally made a piece of clothing, and then I throw it away after 2 wears into the municipal waste stream, so yes, unseparated, then yes, the value is completely
all of
lost.
That has been lost.
All the effort is completely lost. So, and that makes it so difficult. Super interesting discussion. We could go on, I think, for still a long time, but I see Camilla is back here. She's our strict timekeeper. I think we've gone through most of the questions. There was another one in the chat from Jackie, but I think it has been answered in the meantime by another participant. So I hope we can leave it at that. From my side, thank you very much to our excellent speakers, to all the answers you provided, and I'll let Camilla do the wrap up.
Thank you so much, Lutz, and thanks to all the speakers and also to you for all the questions. Real quick, I would like to share 2 more slides really very quickly, just so that you can see what are we planning next. So first, we are going to follow up with the second dissemination webinar on the 14th of April. It will be a little bit longer than today because we have 6 projects to be presented. Here you can see their logos: Sustrag, Glaukos, Grete, Sirpas, Hagded Fashion, and S4 Fashion, among which the last 2 are very recent additions to ECOSYSTEX. So it will be also nothing unlike today. It will be a very interesting discussion, interesting presentations, and we are opening the registrations now for this session. So I would like to ask my colleagues to drop the registration link already to the chat so that you can already subscribe if you would like to participate then again. And finally, how to stay in touch. So there was a discussion about, for example, WhiteCycle's upcoming workshop later this year. And there are many other activities across all the projects. That's why we have an ECOSYSTEX LinkedIn page where we are trying to share all the activities, all the upcoming events, and all the relevant project information. So I suggest you to, of course, follow all the individual projects as well on LinkedIn, but definitely follow ECOSYSTEX as well if you would like to be kept in the loop. And if you know of a project or you are part of a project that you think has a good profile to become a member of ECOSYSTEX, then first please reach out to us to discuss further whether this is indeed a good fit and whether we can move forward with a membership. And with that, on the top of the hour, I would like to thank you, the presenters, Lutz as well, the whole team, and for you to be here with us today. Enjoy your lunch and hopefully see you on the 14th of April. Goodbye.